Hello everyone, welcome to the next session on loud lectures on the engineering mathematics. So far we have already covered 3 sessions on this, and we have covered the questions on linear algebra. We have seen like how small properties makes 1 or 2 marks of good questions and gate, and if we know the properties, we can solve the questions directly in very short time. So that this was about the linear algebra, which we have already done. So welcome back to the next session, and we are here for the session on calculus, right? So now we are moving to the next unit, which is calculus. This will be covering the topics like limit, continuity, differentiability, maxima minima, mean value theorem, Taylor's theorem, Taylor's series, Fourier series, and differentiation, multiple integral, derivative, partial derivative, integration, definite integral, multiple integral, which will move to the vector calculus, and in vector calculus we'll see Gauss theorems, Stokes theorem, Green's theorem, curl, divergence, and gradient, and everything. Right, so one by one we'll be dealing with this. So meanwhile everybody is joining, I'll like people are joining here, so I'll also request like you can share the link with your friends so that we can have the energy and interaction high in the session. And like we all know that calculus is having a good weightage in the subject, overall engineering mathematics subject, and out of 13 to 15 marks which will be asked in your gate examination, you can definitely expect good number of questions, good weightage like in terms of marks, and good questions in the standard, like in the standard manner, right? So, and as soon as the session is over, you should also go for installing the app, looking into the courses you have, registering yourself, and you can avail the course with the best promo codes available. Like you can check the codes available there, right? So meanwhile everybody is joining. Okay, Pranay Seller. Good morning, Pranay. Good morning, Lokesh. Good morning, Heblata. So yes, people are joining and we are already live, right? So in that case, like I have already said that we have a good weightage of calculus in the examination, good number of questions, good standard of questions, right? So today's session, like as already you can see this clipboard, you can see that today's session will be dedicated on the topic of limit, continuity, and differentiability, right? So let's move to the topic and let's start with the questions, and let's see how to solve the questions in a good and I'll say analytical and efficient manner, so that we can save some time also and get the right answer, of course, right? Okay, so here are we with the set of questions we'll be discussing today, and let's start with the first question, which is on limits. So knowing the basics of limit, like how to find the left hand limit, right hand limit, and if only both the limits are equal, then only we'll say that that limit exists at some point. And also we also know the property and concept of L'Hospital rule, when to apply the indeterminate form, and likewise. So carrying all this thing, we'll start with the first question. So let's see this question number 1. it says the value of the limit x tends to 0 for sine x by x square will be how much, right? So it is sine x by x square for x tends to 0. So you can see that it will be taking 0 by 0 form, and for this we can apply L'Hospital rule. So this L'Hospital rule will make you, like, you can differentiate the numerator, you can differentiate the denominator, and in that case you'll get cos x by 2x for x tends to 0. So of course you know that cos x at x equal to 0, or when it is tending to 0, it will be 1, right? We know the graph of cos x. So at x tends to 0, we'll have a value of 1. So now it will be like, this will be a finite value, whereas denominator will be tending to 0. So it will be 1 by 0. Now in this case of 1 by 0, one more thing which you have to take care is, when you will be taking left hand limit, let's say left hand limit, then it is going to be 1 by something very close to 0, right? So when it is tending to 0 with a negative sense, so when it is tending to 0 with negative sense, the ultimate value is going to be minus infinity, right? Whereas the right hand limit, it is going to be 1 by a positive value tending to 0. So in this case it is going to be infinity. Anyways, infinity is not a finite value also, but still what we see is the left hand limit is towards the minus infinity, and the right hand limit is towards the infinity. Like if you remember the graph of 1 by x also, this is going to be something like this. If you remember correctly, this graph is going to be something like this, right? So that is also giving an idea that when x tends to 0, one of it is going to positive infinity, whereas the another one is going to minus infinity. So in that case we can see that the limit won't exist. Both the values are going to be different and it won't exist, we can say. So that makes it does not exist the option D here, right? Let's move to the next question. Second number. Let's try this. You can also use some of the triangular trigonometric properties or identities or some of the formulas which will help you to find the values quickly, right? So let's see this question. It says x tends to 0, where it is the function is x into 1 minus cos x divided by tan cube of x, right? So what does it say? Why not to rearrange it and take some of the standard results which you already have. One of the results which you already have is, although it is a conclusion, but we also have 1 minus cos x divided by x for x tends to 0 equal to, it is going to be 1. But also another result which you have is sin x by x for x tends to 0 equal to 1. And another result we know is tan x by x for x tends to 0 equal to 1. These are some of the results which we already know. So now what we will try to do is, like 1 minus cos x can be written in this form also, and why not to try this form also, like 1 minus cos x. So we know that 1 minus cos 2 theta is 2 sine square theta. So let's write the numerator as x into 2 sine square theta, or let's say x by 2, and in denominator we have this tan cube of x. Now let's divide this tan cube of x by x cube and also multiply it with x cube. So in this case we can see that we are having a standard form here which can be written as this x and this x cube will get cancelled and will be left with x square. So I am writing it as 2 into sine square x by 2 by x square into 1 by tan cube x by x cube, where of course x tends to 0. So to get the standard form, we are dividing it by 2 square and multiplying it with 2 square. Right? Now, using the result sin x by x tends to, when x tends to 0 is 1. So somewhere this value will be 1, and this value is also going to be 1. So ultimately we will have 2 by 2 square, which is simply 1 by 2. So since it is a fill in the blanks, so you should write it as 0.5, not 1 by 2. You cannot write 0.1 by 2. You have to write 0.5. Right? So that means that this is the answer in this case. Let's see the next question. I'll drop this question for you. You can of course try this solving. This is in a very similar manner, and the answer is going to be 1 by 2. So of course you can use some of the same properties used in the previous question, and you can solve this. So let's try the next one. What about this question? Try this if you can. In this case, of course, you can use the conventional method. You can use applying LH rule also. But I'll try to put a different manner in this question so that we can get an idea of approaching in a different manner also, right? So in this case, of course, you can use LH rule. I'm directly saying it. You can use it. But my suggestion is, you know that ln of m minus ln of n will be equal to ln of m by n. So let's use this property first of all. So the numerator can be written as ln of 2 plus 2x divided by 2 divided by x for x tends to 0. So this can be again written as ln of 1 plus x by x for x tends to 0. Now we have seen, like although we haven't started this part, but we have a basic idea that ln of 1 plus x can be expanded in the form of x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4, and so on. The terms keep going on, right? So in this sense, and you know that region of convergence is also less than the mod value being less than 1. So of course we are at x tends to 0, so that doesn't matter. So ultimately this can be written as x minus x square by 2 plus x cube by 3 minus x to the power by 4 by 4 and other terms divided by x for x tends to 0. So you can see only for the first term this term is going to get cancelled, and for other terms it is going to be like x, right? These are like first order, second order, third order, and this is the first order term. So if we cancel out, you'll have something like 1 minus x by 2 plus x square by 3 minus x cube by 4 and so on other terms where x tends to 0. So if x tends to 0, the entire term factors or terms containing x will be 0 and this constant will be left. So this limit is going to be ultimately 1. The only value which will be left is 1. So I'm telling you again, of course you can apply LH rule, of course you can do it conventionally, you should try it also, I'm leaving it for you, but I'm just giving you another sense of like how you can expand the function and even then you can find the limit. So this is important, right? So this is important. Lokesh, hello Lokesh, hello Vadapalli Kalyan. I'm sorry if I am pronouncing your name not properly if it is like that. LH tool, of course for LH rule, L hospital rule, Sahil LH, L hospital rule we are using here, right? So if you have the indeterminate form of 0 by 0 or infinity by infinity, then in that case we should apply the LH tool where it says you can differentiate the numerator separately and differentiate the denominator separately, and then you can apply the same limit, right? So if it is f of x by g of x where x tends to 0, what we can do is, if it is taking by 0 form or infinity by infinity form, then we can find the same limit by applying f dash of x by g dash of x and x tends to 0, right? And if it is still containing the same 0 form or infinity by infinity form, we can repeat this differentiation again for the numerator and denominator, right? So that basic, you can go through the recorded lectures and you can see that we have already discussed the basics of it. We are here to discuss the good questions and doubt lectures on it, right? So if you don't have a small knowledge of LH rule, please refer it. Otherwise, I have given a small knowledge on it. Good morning, Kalyan. So that means in this case the answer is going to be 1, right? So let's move to the next topic, next question. Try solving this. Yes, I. Let's see this question. Under root of x square minus x plus 1 minus under root of x square plus 1, where x tends to infinity. In this case, x tends to infinity. So in this case, we can rationalize it, right? We know that a square minus b square can be given as a minus b into a plus b. So let's rationalize it by multiplying the opposite of it, like it is a minus b. So let's multiply it with a plus b in the numerator and denominator both. Now try solving it. So in that case, what we'll be doing is under root of x square minus x plus 1 minus under root of x square plus 1 into x square minus x plus 1. So it is a minus b. So we are trying to multiply it with a plus b. So under root of x square plus 1 divided by under root of x square minus x plus 1 plus under root of x square plus 1, where x tends to infinity. So this is going to be a minus b into a plus b in the numerator part. Yes, the answer is going to be minus half, Kalyan, correctly said. So in this case, what we will get is the numerator becomes x square minus x plus 1 minus x square plus 1 divided by under root of x square minus x plus 1. Kalyan, if you have done this question like tending to infinity, you should also try it tending to minus infinity, right? Try tending it to minus infinity, where x tends to infinity. So in this case, what next we can do is, we can see that some of the terms will get cancelled, which is x square and x square, and likewise, so what we will be left with is, in the numerator will be left with minus x, and this 1 and 1 also gets cancelled, and the denominator will have this term x square minus x plus 1 plus under root of x square plus 1, where x tends to infinity, of course. So in that case, it will be 1 by 2. It should be 1 by 2. Why? Because you'll be taking out minus x common, not x square, x common, right? So now what we'll do in this case, what we can do is we can take x common in the numerator and we'll be left with minus 1, and in denominator also, if we are taking x common, we'll be left with under root of, let's say, 1 minus 1 by x plus 1 by x square plus under root of 1 plus 1 by x square, where x tends to infinity. So we are cancelling this x from numerator and denominator, and in this case, whenever you have a function like 1 by x or 1 by x square, something like this, and if x tends to infinity, the result will be 0, because the numerator will be finite whereas the denominator will be infinite. So in that case, in this sense, you can say what we will be left with when we are applying this limit, it is minus 1 by, now this term will be 0, this term will be 0, this term will be 0. So we'll be left with only under root of 1 and under root of 1. So this is under root of 1 plus under root of 1, which will be minus 1 by 2. So this is going to be the answer. And in another case, what you can do is you can try solving it when x tends to minus infinity. So if it is tending to minus infinity, when you are taking something common out of the square root, you have to make sure you are taking out minus x, not x, right? That's it. So this is how you can find the value as minus half in this case. So let's move to the next question. Solve this. It is x tends to infinity for 1 plus x square whole to the power of e to the power of minus x. Let's try this. Yes, Kalyan, Shahil. Okay, let's start. So in this case, we can apply the some of the properties of log. So we know that a function, let's say if we have f of x, it can be written as e to the power of ln of f of x. Why? Because this is logarithm and this is anti-logarithm. So we can apply both of it. And in that case, let's say we have this limit y equal to, let's say, this value. So I'm writing it in the sense of log and anti-log, which can be written as e to the power of ln of 1 plus x square to the power of e to the power of minus x, where x tends to infinity. Now the property of log says ln of m to the power of n can be written as n times of ln of m, right? So that means this can be written as e to the power of e to the power minus x into ln of 1 plus x square, where x tends to infinity. So let's focus on this part. Let's focus on this part where x tends to infinity, right? Of course, this is not having any x term. So let's try to solve this first. So what we have is e to the power of minus x into ln 1 plus x square, where x tends to infinity. And this can be written, the answer is 1, Kalyan. I think yes. E to the power 0 will be yes. E to the power 0 will be 1, correct. So this will be written as ln of 1 plus x square. Try the next question if it is visible to you. So divided by e to the power of x, where x tends to infinity. Now if you see, if x tends to infinity, this will be ln of infinity 1 plus infinity square and divided by e to the power of infinity, which will also be a very high value. So in this case, we will have infinity by infinity form, and we can definitely use LH rule here. So in this case, what we will do is we will differentiate the numerator and denominator and then apply the limit again. So I'm writing it here. This becomes, the numerator will give you 1 by 1 plus x square into 2x, right? So this is the differentiation of numerator, and denominator will be having e to the power of x, where x tends to infinity. You can again see the numerator is x, so this will be tending to infinity, this will also be tending to infinity. Although I'll give you one suggestion here afterwards when we'll do this conventional method, that this, you can directly say that this function is going to be 0. But let's see how. So this is going to be infinity by infinity, and you can apply the LH rule again. And for e to the power of x into f of x, the differentiation can be written directly as e to the power of x, f of x plus f dash of x, if you remember correctly. If it is e to the power of x into f of x, that means the numerator will be 2 and denominator is going to be e to the power of x 1 plus x square and differentiation of 1 plus x square, which is going to be 2x, where x tends to infinity, right? So in this case, the numerator is going to be finite, whereas the denominator is going to be infinite value, which is 0. Right? This value is going to be 0, which means the limit which we are trying to find here, the limit which we are trying to find here, this one will be nothing but e to the power of 0. So y will be e to the power of 0, which is going to be simply 1. Right? We were trying to find the limit of this function e to the power of minus x into ln 1 plus x square, where x tends to infinity. This is what we are doing it here. See this, where x tends to infinity. And what we found is this value is going to be 0. So that means y will be e to the power of 0, which is 1. So C is the answer. Kalyan, the answer is 3. I'll have to check if it is 3. You are telling the value of b is 3, correct? And what is the limit? Please try that also. What is the limit of this value? Try that also. I think b is equal to 3 is correct, but you will also have to tell the limit. What limit it will extend. So the next question, it says, is there a number b such that this limit exists, and if so, find the value of b and the value of the limit also. So we have to find two things. We have to find b if in any case we can find the limit, and if it exists, what is that limit going to be. So we have to find two of this. Please explain e to the power of x f of x. Okay, this is a basic differentiation, right? Like just imagine if you have e to the power of x into cos x. So by product rule, what you'll be differentiating, how you'll be differentiating, it will be first you'll differentiate it and keep this, and then differentiate this and keep this, right? So it is going to be e to the power of x. If I am differentiating e to the power x, it will remain e to the power x into v. Let's say this is u, this is v, into cos x plus, let's keep u like that and differentiate v. So this is going to be minus sin x. So now what you can do is you can take e to the power x common and write it as cos x minus sin x. So if you see correctly, this is nothing but e to the power of x into f of x plus f dash of x, where this was f of x. F of x was cos x. Right? So we can, like, to save some time, Kalyan, 1 minus 1. Yes, the limit will be minus 1, correctly said. It is going to be minus 1, where the b value will be 3. So this is clear, e to the power of x into f of x. These are some of the basics which helps you to find the differentiation easily. So in this case, if you have to find the limit of this function, if you see that it is bx square plus 15x plus 15 plus b divided by x square plus x minus 2, where x tends to minus 2. If you see it properly, the denominator will tends to 0, right? This is 4, this is minus 2 and minus 2, which will be 0, and maybe this numerator will be something, right? So if you want that limit should exist, what we should do is we should try to make it of the form 0 by 0, so that then we will be eligible, or it will be eligible that we can apply the LH rule, so that we'll differentiate numerator and denominator and then again put the LH rule, right? So this is possible if along with denominator, numerator is also tending to 0 when x tends to minus 2. So that means bx square plus 15x plus 15 plus b for x tends to minus 2, yes, Sahil, should be equal to 0. So if you apply minus 2, it is going to be 4b minus 30 plus 15 plus b equal to 0. This will give you, let's say, 5b equal to 15 and b is equal to 3. That means if b is equal to 3, when x tends to minus 2, the numerator will also tends to 0 and denominator will also tends to 0, and then you will be able to apply LH rule. Then you will be able to apply the LH rule, and what this LH rule will give you, let's see that also. So once this b is equal to 3. So let's say for b is equal to 3, let's see what the numerator will be. The numerator will be 3x square plus 15x, and putting b is equal to 3, it will be plus 18 divided by x square plus x minus 2, where x tends to how much? Minus 2. Right? Of course, you can convert into a proper rational function also. This is not in a proper rational function. You can convert it also, and then also you can find the value. Otherwise, you can clearly see that we have already said that now this will be taking 0 by 0 form. So without putting it, I'm directly putting it like it will be 0 by 0 form, and now we can use LH rule. And this LH rule will give the numerator to be 6x plus 15 and denominator as 2x plus 1, where x tends to minus 2. So this is going to be 12 plus, I'll say minus 12 plus 15 and minus 4 plus 1. So this is going to be 3 by, this is minus 3 is equal to minus 1. That means for b is equal to 3, the limit will exist and the value will be L is equal to minus 1. Correctly said, right? Yes, Kalyan? Okay, so let's move to the next question, and this question is on continuity. This is on continuity. It says for f of x is equal to x square sine 1 by 5x plus 5 for x not equal to 0 and equal to k for x equal to 0. For the function being continuous, what should be the value of k? What should be the value of k? So that we can have this the continuity. So for continuity, we know one thing, and it is for function being continuous, the limit f of x for x tends to, let's say, a should be equal to the function value at x is equal to a for continuous function. This is the condition, right? So for x not equal to 0, we have this function, whereas for x equal to 0, we have this function. So that means that, and we have to check it at x equal to 0. Of course, for other values, it will be, for other value, it is going to be continuous, and you can check it why. Of course, I can also tell you k should be equal to 5. Yes, Kalyan, k should be equal to 5, correctly said. And of course, you would have applied, of course, you can like see, check it, and if you are in a good practice, you can check it and you can say that the value is going to be 5. If not, you can apply squeeze theorem here and you can find the value. So let's see. So in that case, the function will be continuous for other values apart from x equal to 0. You will have to check this. I can help you on this, but of course you can check it also. But other than that, so we are checking this function at x equal to 0. For this, we need to find the limit of the function for x tends to 0. So what is it? It is going to be x tends to 0, x square sine 1 by 5x. Yes, Lokesh, 5 will be the answer, plus 5. We have to find this. Now here what I'll suggest you is to apply squeeze theorem for this part. Squeeze theorem for this part. For this part, it is a constant, so it will add up, just simply add up. So we know that sine 1 by 5x for any of the x value will be between minus 1 to 1. Right? Sin x is limited or bounded between minus 1 to 1. And of course, what if we multiply x square on both the sides? We will have minus x square times of sine 1 by 5x between x square. And this is where we can apply the limit. So the limit is for x tends to 0. So let's do it here itself, x tends to 0. So the squeeze theorem suggests that if a function lies between two of the function f of x and g of x, for in this case it is minus 1 and 1, or x square and minus x square in the second step, then when the limit x tends to some value, if these two values are going to be same, then the limit of this function is also going to be same. So if you limit the function for x tends to 0, it is going to be 0 and x square sine 1 by 5x for x tends to 0 will be between 0. So ultimately you can see that this limit is going to be 0. So this means that the limit of this function for x tends to 0 is going to be 0 plus 5 or simply 5. So this limit should be equal to the function value at x equal to 0, which is k. So this means these two values are supposed to be same and k will be equal to 5. That's it. So that means the value of k should be 5 so that we can get the answer. Yes, Lokesh, correctly said. 5 was the answer. Let's move to the next question. Let's try this. Yes, so for what value of k the function is continuous, right? We have to see that this function is continuous. If it is not clearly visible, I'm writing it for you. X cube plus 2x divided by mod x if x is not equal to 0 and it is k if x is equal to 0. This is your function. Yes, try solving it. So for x not equal to 0 and for x equal to 0 it is given. So again, if this function is continuous, the concept is that the limit of this function for x tends to, in this case it is 0, equal to 0 and divided by f of x equal to 0, right? So we are checking it for the limit, we are checking it for the continuity, we are checking it x equal to 0. For other values it will be continuous. You can check it and I can explain you how also. But for now what we want to do is, if we have to check the continuity, we'll have to do it at x equal to 0. So the limit and the function value at that point should be same. Lokesh, 0 is not the right answer. Kalyan, 2 is also not the right answer. Please try it again. So let's see. Let's start with the limit, so that if we know the limit, we can compare it with the function value also, right? So we have this function equal to x cube plus 2x divided by mod x and no such value. Yes, Kalyan, D option, Lokesh, correct answer. No such value will exist. Why? Because numerator is going to be x cube plus 2x divided by minus x for x less than 0, and you can write it x cube plus 2x by x for x greater than 0. Correctly said? Yes, D is the answer. Kalyan, D is the answer. So you can see that this is going to be the case because mod x is minus x for x less than 0 and it is x for x equal to or greater than 0, whereas in this case x, this is not the function for x equal to 0. X equal to 0 is this case, right? So I'm not including x equal to 0 also, right? So in this case, now what we have to do is we have to check the limit. So if we can check the limit and if the limit exists, then only you can compare it with the function value, correct? So in this case you can see when x tends to 0, I'm writing it x tends to 0 minus in this case and x tends to 0 plus in this case. You can see it is going to be 0 by 0 form and this is also going to be 0 by 0 form. So in that case you will apply LH rule, and if you apply LH rule, the numerator now for the function value is going to be 3x square plus 2 divided by minus 1 for x tends to 0, and for this case it is going to be 3x square plus 2 divided by 1 for x tends to 0. Now you can see then when x tends to 0, the numerator, the left half part, this is 0 minus, and this is 0 plus. It is understood because we are taking the condition x less than 0 and x greater than 0, right? So in this case, it is going to be 2 by minus 1, which is minus 2, and this is going to be 2 by 1, which is 2. So you can clearly see that these two values are not same. These two values were supposed to be same so that the limit will exist. So limit does not exist. And if limit does not exist, you cannot find a function to be continuous for any function value. So in that case, if limit does not exist, no k value can make this function continuous. No k value can make this function continuous because the limit is independent of k. Had the k been a factor so that the function could have been made, that the limit was possible, then only k would have helped you. But here we cannot help the limit because it is independent of k. So in that case, we can say that no such value of k can make this function continuous. Clear? No such value can make this function continuous. So let's move to the next question. This is a very small, I'll say 1 or 2 marks, I don't remember. This is from civil department. Which department you people are from? If you will help tell me, that will be good. Because this question is from civil 2011 or 12, I think. And it is a very, I think it's 1 marks question or something. So let's try this. What should be the value of lambda such that this function, if it is visible, lambda cos x divided by pi by 2 minus x for x not equal to pi by 2, and otherwise it is 1 for x is equal to pi by 2. So again, you have to make the limit equal to the function value at that point x equal to pi by 2. So let's see what is the limit. F of x for x tends to pi by 2. It is a very small and straight question. Of course, you can solve it easily. Lambda cos x pi by 2 minus cos x for x tends to pi by 2. This will be 0 by 0 form. So you'll apply LH rule, and applying LH rule, the numerator will become lambda into minus sin x, and denominator will become, okay, it is cos, sorry, it is x. It is x. So denominator will become minus 1 for x tends to pi by 2. So when you put this x equal to pi by 2, this is sin x will be 1, minus minus gets cancelled, and it is lambda. So this is what should be the value of lambda, sorry, pi by 2 value at the function, right? This is the limit should be equal to the function value at pi by 2. So what is this? Limit lambda, which is equal to 1 as given, right? See this, the function value at x is equal to pi by 2 is 1. So lambda should be equal to 1. That's it. Ez. What is this Ez? I didn't get it. Option C is the right answer. What is that, Lokesh? Anyways, so very simple, in the like we have already done in the previous 2 questions. That is what we have to do here also, right? So it is done. So let's move to the next question. The answer is lambda equal to 1. Fine. C option. Easy, right? Easy. This was your mechanical, no, civil 2011 question. See, of course it is easy. The difference is whether you are spending like 1 minute or 5 minutes in this question. That is important. Like in gate questions, you'll see that many of the time questions are easy. But what is important is if you are spending less time, then only you are utilizing the easy question. You are spending less time, and then you can use that time in the questions which will be difficult. And that is where you will create a difference with other students sitting beside you who can also solve this question. Right, so that is the main strategy you should have while attempting for the gate or examination. So let's see this question. This is from differentiability and continuity both. So it says the function is mod of x minus 2 to the power of 5 by 3, and the interval is also given, and you have to see that at x is equal to 2 whether the function is continuous or differentiable or non-continuous or non-differentiable, anything like the option says. So let's see this. F of x. First of all, you can see that where this x minus 2 will be equal to 0. This will be equal to 0 for x is equal to 2. That means x minus 2 will be equal to x minus 2, or it is going to be 2 minus x, depending if x is greater than 2 or x is less than 2. Of course, you can put greater than and equal to both, that is fine. So if the value is going to be greater than 2, you'll write x minus 2. If it is less than 2, you'll write 2 minus x, right? So in this case, the function f of x is equal to, I'll write 2 minus x to the power of 5 by 3 if x is less than 2, and x minus 2 to the power of 5 by 3 if x is greater than equal to 2. Now, first of all, you should check the continuity. First thing which you should do is check the continuity. So let's start with the continuity first. Because we know only if the function is continuous, then only we can check for differentiability. If the function is not continuous, we can straightforward say that the function is non-differentiable at that point. D option, neither continuous nor differentiable. I think you are not right. Please check again, Kalyan. D is not the right answer. Let's see. First of all, let's see the continuity then. So continuity will be checked at x is equal to 2. Of course, they want it at x is equal to 2. So for x equal to 2, the limit of x for 2 minus will be how much? This 2 minus x. So 2 minus 2 to the power of 5 by 3 equal to 0. And f of x right hand limit 2 plus will be 2, again 2 minus 2 to the power of 5 by 3. So that will also be 0. Also the function value at 2 is also 0. So you can clearly see that all three values are going to be 0 in this case. The left hand limit is 0, the right hand limit is 0, and the function value is also 0. So first thing is very clear that the function is continuous. The function is continuous. It is not discontinuous, right? There is no discontinuity in this function. It is continuous function. Now the second point of consideration is differentiability. So for differentiability, what you can do is, again for x is equal to 2, we are checking the, we'll have to check the left hand differentiability and right hand differentiability, and we have to compare it. If it is same, we'll say that the function is differentiable, right? So we know that this function is f of x is equal to this and this. So f dash of x, let's write the derivative, take the limit at x equal to 2, the left hand and right hand limit, and check if both the values are same. So the derivative for this case is going to be 5 by 3 into 2 minus x to the power of 2 by 3 and into minus 1. Why minus 1? Because it is 2 minus x. So it is minus x. So now what you can do is you can apply the limit in this case for x tends to 2 minus, because it is for the case of x less than 2, and also it is going to be 5 by 3 x minus 2 2 by 3 for x tends to 2 plus. We are trying to find the derivative at these 2 points. So what I have done is, instead of doing the conventional method, which is f of x naught plus h minus f of x naught divided by h, where h tends to 0, you can apply that method also, right? F of 2 plus h minus f of 2 divided by h for h tends to 0. You can apply this also. But what I am doing is, for the left hand and the right hand, I am putting the limit derivative and taking the limit for x tends to 2 minus, x tends to 2 plus. So in this case, you'll see when you put 2 minus, this term will get 0 and you will find it to be 0. And similarly, when you put 2 plus, then also this term will get 0 and you'll get it to be 0. So you can see the left hand limit, left hand derivative is equal to the right hand derivative. So this means this function is continuous also and differentiable also, right? Locase, whatever you wrote, I didn't see and you have now deleted, but whatever it was. So Kalyan, did you get it? The function is going to be continuous also and derivative also. I mean, the differentiability will also be there. So you can say that in this case, the function is continuous and differentiable both. So that means the answer is option A. It is option A, right? So you don't have to be very quick while solving it, and like, I mean, don't be wrong. At least if you're trying to be fast, it is very good, but you have to make sure that you're not doing any mistakes. So in this case, because why I am saying it, because this order of 5 by 3, I mean, if it had been mod x, it would have been a sharp bend coming down and then sharp bend and then changed. But when it is to the power of 5 by 3, there will be a gentle curve at this x equal to 2. There will be a gentle curve at x equal to 2, and because of which the derivative at that point will be 0. It won't be non-defined, it won't be undefined, it will be 0, because it will be like there will be a gentle slope at x equal to 2, where you'll see the function will change its nature, right? Yes Kalyan, yes Lokesh. So you can see that the function is going to be continuous and differentiable both. So this is done. Let's see the next question. Had this been mod x, it would have been a very sharp bend, and a sharp bend makes it not differentiable. I am suggesting you to solve this question graphically. My suggestion, or even I'll be doing it graphically. Let's not do it on like while solving it. Let's try doing graphically. So first of all, let's talk about a function. Let's talk about a function g of x, which is x square minus 4x plus 3. Let's talk about this function. So this is a second order function, or you can say quadratic function. And of course, you can also find the roots. You can tell me the roots. The roots are going to be, you can see this is going to be minus 3 and minus 1. So minus 3 into minus 1 will give you 3, and minus 3 plus minus 1 will give you minus 4. So the roots are 1, 3. Right? Kalyan, 2. What is that 2? I didn't get it. Number of points where the function will be non-differentiable. Right. The number of points is 2. Correct. 1 and 3 is the point where the function is non-differentiable. Correct. But have you tried solving it graphically or like in the conventional method? So I want it to be solved in graphical method. So we know that a second order equation will be a parabolic form, right? And that too, if we know the roots, this is 1 and let's say this is 3, then we can say the function value at like g of x. So g of 0 will be how much? 3. So somewhere at this 0, 3, this function will be passing, and it will be like this. Let's say like this, right? This is going to be the function. Now they want us to find what is f of x. F of x is mod of g of x. So if it is mod of g of x, in that case, what will happen? We will have to, like, whatever value is positive, but whatever value is negative should be inverted, right? So this value has to be inverted. In that case, the graph is going to be like this. So this is 1 and this is 3. So at both this point x is equal to 1 and x equal to 3, there will be a cusp at x equal to 1 and x equal to 3. That means a sudden change in your graph nature. It was coming down and then suddenly it went up. So this sudden change brings the cusp at these 2 points, and the function, if you are analyzing it graphically, you will see that at 3 points, I'll write it here, at 3 points the function is not going to be continuous. The first point is while checking it graphically. If there is a discontinuity, so a break, if there is a break, right, a function like this, so there is a break at here, right? or there is a bend, you can name it as cusp, or when you can see like the slope is vertical slope, that is also counted here. So in that case what you'll see is that this sudden cusp, because this like mod x also we have seen it is not differentiable. Why? Because there is a sudden sharpness, sudden bend at this point. So because of this bend, because of this cusp, or because of this break, for all these cases the function is going to be non-differentiable. That means the function is non-differentiable at 1 and 3 both. So the number of points is going to be 2. Clear? Let's try the third question, which is small and easy one. Let's try this. So it says determine the value of a and b where the following function is continuous and differentiable both. So we have this f of x. It is a simple question. This is x square minus 2x and ax plus b for x less than 0 and x greater than equal to 0. So let's start with the continuity. For continuity what we need is that x square minus 2x, in this case what we can make it for x tends to 0, f of x for x tends to, let's say, 0 minus, this is going to be 0, and f of x for x tends to 0 plus, it is going to be b, and function at x equal to 0 is also going to be b. So that means these three values are supposed to be same in this case, right? So for being same, 0, b and this b are supposed to be same. So 0 equal to b. That means first of all the b is going to be 0, b option. B is the right option, correct? So if b is equal to 0, this function now I'm changing it and this becomes f of x is equal to x square minus 2x for x less than 0 and ax plus 0 or directly ax for x greater than or equal to 0. Now you check for the differentiability. So let's say derivative. So the derivative in this case is 2x minus 2 and in this case it is a, and we have to check the left hand limit at x tends to 2 minus x tends to 2 plus. So for 2 minus this is going to be how much? Minus 2, and this is a. I think it is 2, sorry. So this a is going to be minus 2. Right? So we can see that this function for being continuous and differentiable, what we need is the derivative. So derivative at this case it is going to be 2x minus 2, and for this case it is going to be how much? A, simply a. So for x tends to, it is not 2 minus, it is 0. Tends to 0 minus and tends to 0 plus. So it is going to be minus 2 and this is going to be 2. So a should be equal to 2 and b should be equal to 0. If this is also done, so we have the answer equal to b. Clear? X tends to, yeah, x tends to 0, correctly said. Apart from this, some of the other questions which you may come across is, I'll tell you one of the expressions which you generally come across. This is f of x is equal to 1 plus x to the power of 1 by x, where x tends to 0. So you can take this as a conclusion, and you may come across more questions on this also, where this is going to be e to the power of 1 simply, right? Similarly, the other result which you may come across is 1 by x for x tends to infinity. In this case also the result is going to be e to the power of 1 or simply e. So sometimes what happens, you may get an expression where this function is raised to some power. So if there is a property, if you know, the limit of g to the power of x to the power of n for x tends to, let's say, a, can be given as the limit x tends to 0, or a in this case, to the power of n. So there was a direct question on, like in GATE, and it was like 1 plus 1 by x 2x for x tends to infinity. So you can see that this function is being written twice. So you can bifurcate it also, and you can find it the value is going to be e to the power of 2. Right? So these are the different types which you come across in the GATE question, and you have to make sure that you know all the properties. The properties help you to solve the question quickly. Like you have to know the squeeze theorem also, you have to know the LH rule also, you have to know the limits, the derivatives, and some of the time you can also try solving it using f of x naught plus h minus f of x naught divided by h, where h tends to 0. That will also help it. But if you know the derivative, you can put the derivative on both the end, and you can compare the left hand derivative and right hand derivative where x tends to 0 or maybe a or whatever value it is. So a minus and a plus both, right? So likewise, what we can do is, so let's keep it till here, and these are the types of question you can expect, and of course other functions, other complicated functions also, but using the same knowledge and same concept. And in the next class we'll try to move into the next topic, which is maxima, minima, mean value theorem, Taylor series and Fourier series, and other topics, right? And maybe in a couple of classes, maybe it will take 1 or 2 more class, and then we'll be switching it to vector calculus. I'm sure many of us are waiting for vector calculus also, so we'll be doing it also, right? And of course you can check the recorded classes also. So for all the everyone here, it was really a good session, an interactive session. We were actually interested, and it was good going. So you can also put a thumbs up on the video and share with your friends, so that we can have a good and more energy in the next class with more number of friends. And of course you should install the app. Like you must be getting the link for this, so you should install the app, log in or register yourself, and check the courses you have, so that you can also get to the knowledge of recorded classes, where we have already dealt the concepts and lectures, theory part, so that we can directly get into the questions now, right? So for now it will be over, and in the next class we are going to move to the next topic. Okay then, thank you everyone, thank you Lokesh, Kalyan, everybody. Okay then, bye bye.